Right, and welcome to another video on A-level maths. And this is in chapter 3 for year 13, year 2 book on sequence and series. And in this video, I'm going to try and do what? Try and recap the whole chapter in about 15-20 minutes, okay? So we will not do many easy questions. All right, anyway. Number one, guys, where do we start from is the difference between a sequence and a series. In one line, not much for you guys. Sequence is when terms are given to you with a comma sign in between, and series is when terms, it's a sum of those terms, okay? There are two types of series you given in this chapter. I call A for arithmetic and G for geometric, right? And what we need to know the formulas, or how do we find the next term, or we call the nth term of both of them. Then we need to know how do we find the sum of terms of both these sequences in series, arithmetic and geometric, okay? How do they differ from each other? Arithmetic, when each term adds or taken away, or adds or subtracts by the same amount. And geometric series is when each next term is multiplied by same amount. Okay, and you can say it can be divided as well, same as add and taken away. And this thing which adds or taken away from each term to get to the next term is called the common difference, the notation. And here we call it common ratio for obvious reasons, because this is multiplied, okay? And the first term in both of them, we call it A. All right, then the next step is, guys, how do we find the formulas for this nth term and the sum of terms, okay? I'll write down for you now. All right, so in arithmetic series, the series goes like this. A is the first term, then A plus D, because you add D each time, then A plus 2D, and so on. So the nth term would be A plus some D's. How many? Let's check. First term's got 0 D's. Second term's got 1 D. Third term's got 2 D's. I'm pretty sure you figured it out. It is the term number take away 1. So we're finding the nth term. The term number is n, so n take away 1. Brilliant. In geometric then, how do we find the nth term? It is A, the first term, then we multiply it with R, then multiply with R again, and so on. All right, guys, the nth term in here, un, what's happening? It is what? The R is actually 1 less than the term number, so it's AR and minus 1. So fairly simple. There's not much, work in this to figure it out, and you don't need to memorize. You can just figure this out formulas yourself. Now we will move on to sum of the n terms. All right, to find the sum of n terms of arithmetic series, guys, the proof is important. And what do we need to do? You just remember one thing. You got to write down in reverse order, the whole series in reverse order, and then add vertically. Just remember these two things down, given in the textbook. You can work this proof out. If not, I'll probably do this another video when I do exercise by exercise, okay? This is just a recap of the whole unit, okay? So the formula you get Sn is n over 2, 2a plus n minus 1d. All right, guys, it's not very difficult to understand. Once again, you write the series in reverse order. Underneath this, then add vertically. You'll see the sum of the first term and the last term, second term and the second last term and the first term, and second last term, the second term, give you the same thing, and then you can add them together, okay? For this one, the formula is, the type is, guys, you're going to multiply by R, and then you have to do what? You have to take away. So these are the things I'm expecting you to memorize. For here, reverse order, add vertically. Multiply by R, take away. What does that mean actually? If this is Sn, you do RSN, which is AR plus AR square, and so on. then you take away the 2, guys. You're going to get the formula as Sn is 1 minus r at the bottom, so a 1 minus r to the power n, or r minus 1 at the bottom, so a r to the power n minus 1. Right, I have been asked this by people in the past, that how do we memorize which formula to be used? Very simple. You just say to yourself, the denominator cannot be what? Denominator cannot be negative. If your r is less than 1, then 1 minus r is a positive thing. This is the formula. If your r is greater than 1, then r minus 1 is a positive thing. This is the formula. Very simple. Denominator cannot be negative. That's how you memorize which formula to be used. Okay, so this is about the sum formulas. Then there's another formula which comes into geometric series. It's sum to infinity. And I did in the past, people have asked me, how can you add terms to which goes on and on forever? The idea is, yes, guys, they're called convergent sequences, convergent series. We'll talk about that later in detail. It's very easy to memorize. This is a over 1 minus r. And convergent means terms have to get closer and closer to some values. This will only work when r is less than 1. In fact, when r is actually in between minus 1 and 1. This formula is only valid for this. That's another important exam question. They ask you, when is this formula valid? Okay, can we find sum to infinite series of a geometric series? And you got to check if r is between this range, then you can, otherwise you can't. Okay, guys, move on to the questions now. All right, 2 simple basic questions. Find the nth term of this sequence. First of all, is it arithmetic or geometric? Let's see what happened, people. Add 4 is arithmetic. Okay, so we use this formula to find the nth term. This is, first term is 2, so 2 plus n minus 1 times 4. You simplify this expression. I leave that to you. For this one, people, check. How do we find? If you add, you're actually taking away 12 from it, then you're adding 24. That doesn't work. Okay, so try something else. Times negative 8 divided by 4, it's negative 2. So it's times by negative 2 times by negative 2. This is geometric series. All right, so we're going to find the nth term for this geometric series. This will be a, which is 4, and times r n to the power r to the power n minus 1. So r is negative 2. 4 times negative 2 to the power n minus 1. I leave that to simplify yourself. Okay, how do we find the sum of n terms for these 2 sequences there, people? For number 1, it is n over 2, 2 times a, plus n minus 1, and times 4. Thank you. Simplify this. And number 2, this will be r is less than 1. Is that right? R is negative 2. So we'll be using this formula. So Sn is equal to a, which is 2, 1 minus 2 to the power n over 1 minus 2. Simplify this. That's how you find the sum of the n terms of this geometric series. These are the simple questions. Move on to something trickier. But before that, let me just introduce the other things which are left, the sigma notations and the modeling and other stuff with the series. Okay, I've selected these 4 questions to explain everything in sigma notation you need to know. Okay, so there you are. What does this actually mean? You've seen this symbol in Excel. This is the sum symbols. What does that mean? You're going to add all the terms from 1 to 20 for this series, this sequence. Obviously, when you're adding them, it becomes series. Okay, so what does that become, people? First of all, you're going to check what type of series is this. So put the first value of r you're given with. 7 minus 2r is 5. Then next value, 7 minus 4 is 3. Then 7 minus 6 is 1. So 7 minus 8 is minus 1, and so on. So you can see this is an arithmetic series. You know what your a is. Okay, 5. You know what is r is. D is, minus 2, and you know what n is, 20. So add them together. Very simple. Use this formula there. Okay, same question coming over here. So what do we do, guys? We got the series there, but what do you think we need to do here? You're going to add terms of the series which starts from the 5th term. So none of these 4 which I've written over there will be added. So what do we need to do, people? We got to actually find the sum from 1 to 20, then take away sum from 1 to 4. Okay, so you can find the 2 sums. 1 to 20 we already found here. take away sum from 1 to 4 using the same parameters. A equals 5, D equals -2, but N this time should be equal to 4. Remember, 5 is needed. Okay, you need the 5 terms. Or what people do, they will do what? They'll put R equals 5 to find the first term, which is -3. Then R equals 6 to find the second term, which is -5, and so on. But remember, in this case, if they choose to do this question this way, you are adding 16 terms. This is really important. People just do 20, take away 5, and they say we're adding 15 terms. Actually, you need the fifth term. What you do not need is first 4 terms. That means you're adding the 16 terms. Okay. Similarly, over here, we can write the sequence first. This is 3 times 4. Then 3 times 4 squared. Then 3 times 4 cubed. Okay, and so on. We're adding 10 terms. That's your A. R equals 4. So at N equals 10, add 10 terms. Okay, guys, same thing over here. We're going to find sum to infinity, but starting from the 10th term. So what you should do here in this case, you're going to find sum to infinity from the beginning, take away from it sum of the first 9 terms. Try and understand the difference, people, in these two questions. They're very important, and I've seen people making a lot of mistakes in this. Anyway, we move on to the next type, which is the recurrence relation. Okay, this is how the recurrence relations look like. What happens is that the next term is related to the previous term. Sorry, that should be 2un. Okay, so next term, n plus first term, is related to nth term. Okay, and plus 1, let's say, right? That's over here. Right, peoples, what you need to do in this case, you got to make sure that you find all the first few terms to see what kind of series or sequence it is. And you will always be given the starting point. So u1 is 2, u2 is twice of u1 plus 1. You see what I've done is I've put n equals 1 there on both sides. So it becomes u2 there, u1 there, which I've got u1 already, which gives me 5. So u3 is twice of u2 plus 1, which gives me 11. So you can see 2, 5, and 11. This is neither of arithmetic or geometric series. So be very careful. Find the first few terms. Let's check this one over here, people. Okay, u1 is 2. So u1 is 2. u2 is equal to 2 squared minus 1. This time, on purpose, I did not write is the u1. I've just, your first term is 2, so you just put that in straight away. This is 3, so u3 will be 3 squared minus 1. Remember, I'm saving a step there. Okay, that gives me 8. So once again, I check. It is neither of arithmetic or geometric series. So very, very important point to understand. Your recurrence relations might not end up in any of the known series Okay, and the problem solving recurrence relations can be just understanding how the one term is related to the others, and they can put some algebra in all these questions. Actually, there can be a lot of algebra coming in. This is the chapter, guys. Recap, I'll do it detailed every exercise, and we'll do that in another video. Okay, guys, well done. Enjoy learning. Bye.